Alright, good morning viewers. Today we'll be looking at types of machines. And this is the second type of machine, the block and tackle pulley system. In the previous class we looked at the lever system. There we are made to understand the three types of lever: the first order lever, second order lever, and the third order lever. And then we solved the question on the lever system, applying the principle of moment. So today we'll be looking at the block and tackle pulley system. This diagram shows us the diagram of a pulley. This one has 4 pulleys attached to it. If you observe, there are about 4 pulleys attached, and this is a load. And an effort is applied at this end of the rope. Okay? This other one has 5 pulleys attached to it. And then a load is at this point, an effort is applied at this other end of the rope. Okay, so let's observe the diagram. Shows us the block and tackle pulley system. Okay, so that one shows us 4 pulleys, and this other one shows us 5 pulleys. So you see that for the 5 pulleys, you have 5 round circles. Those circles there you see are the pulleys. And then a rope is connected to each of these pulleys. An effort is applied at this end. You see, an effort is also applied at this other end. Now, on application of efforts, the pulleys will rotate and the load will be lifted up, or it can be pulled down based on how the effort is being applied. Okay, so the load is at that other end. This one shows you 4 pulleys. The 4 pulleys is an even system of pulley, while the 5 pulleys is an odd system of pulleys. Okay, so that is the block and tackle pulley system, the second type of machine. Alright. Okay, it says this is the more practical system of pulleys in which one or more pulleys are mounted on the same axle with one continuous rope passing all around the pulleys as shown in the figure. Alright, so it says in a block and tackle pulley system, the velocity ratio is equal to the number of pulleys in the system. I'll repeat again. In a block and tackle pulley system, the velocity ratio is equal to the number of pulleys in the system. Alright, so we see here that in this particular pulley, we have about 4 pulleys. 1, 2, 3, 4. That means our velocity ratio there is what? Is 4. So for the velocity ratio of this number of pulleys is 4. So we are told that the formula for velocity ratio of a block and tackle pulley system is the number of pulleys in the system. So if you have 4 pulleys, 1, 2, 3, 4, the velocity ratio is 4. And if you have 5 pulleys, 1, 2, 3, 4, 5, the velocity ratio is 5. So velocity ratio of a block and tackle pulley system is equivalent to the number of pulleys in the system. So the velocity ratio of this one is 5. And the velocity ratio of this is 4, since you have 4 pulleys. Alright. Okay. So velocity ratio of a block and tackle pulley system is equal to number of pulleys in the system, is also equal to the number of ropes supporting the pulley. The number of ropes supporting the pulley as well. Okay. So let's look at this one. The number of ropes, you have 1, 2, 3, 4. Okay. 4 ropes. That's velocity ratio 4. Then look at this other one. 1, 2, 3, 4, 5, and 6. Sorry, 5 rather. 1, 2, 3, 4, and 5. So it's equivalent to 5. The velocity ratio is 5. So most times we don't actually consider the number of ropes. With the basic formula we use is the number of pulleys in the system. So for this one now, you have 1, 2, 3, 4, 5. So the velocity ratio is 5, okay? And this other one is 1, 2, 3, 4. The velocity ratio is 4. So this is the basic formula we make use of in solving the block and tackle pulley system. The velocity ratio of the block and tackle pulley system is basically the number of pulleys in the system. So it is only on rare cases that we make use of the number of ropes supporting the system, okay? Okay, let's look at this question. It says, the diagram below represents a block and tackle pulley system on which an effort of 50 Newton is just able to lift a load of weight W. If the efficiency of the machine is 40%, find the value of W. Find the value of W, okay? So this is the diagram given to us. The diagram given to us in that question, okay? And we are asked to find the value of W. W shows us the weight of that box. The box that is attached there, the weight of the box, that is the load. Okay, so the effort is applied at this other end of the rope, and the 50 Newton, the effort is 50 Newton applied at that point of the rope. So let's count the number of pulleys in the system. You have 1, 2, 3, 4, 5, 6. So since there are 6 pulleys, 1, 2, 3, 4, 5, 6, it means that the velocity ratio of that pulley system is 6. Okay, so I'll indicate that. I say velocity ratio equals to number of pulleys in the system. So it means that VRO will be equals to 6. Velocity ratio there is 6, which is the number of pulleys in the system. Okay, and then we'll come back again to that diagram. You see that an effort of 50 Newton is applied. So I'll say my effort E is equals to 50 Newton. Alright, now we are asked to find the value of W. The value of W is the weight. So I say load L is equals to W. W is unknown. Okay, then we come back to the question. It said if the efficiency of the machine is 40%, we are given the efficiency of that machine as 40%. Alright, so we are told that the efficiency is stylish E is 40%. Okay, so let's solve that. Now the formula for efficiency of a machine is its mechanical advantage divided by the velocity ratio multiplied by 100, and it is measured in percentage. Okay, so the efficiency is 40%. Converting 40% to a fraction, that is 40 divided by 100. So this 100 comes down as the denominator, is equals to the mechanical advantage is unknown. The velocity ratio of that pulley system is 6. If you can recall, we said velocity ratio is the number of pulleys in the system. So the velocity ratio is 6. Okay, so our velocity ratio is 6 in that pulley system. Alright, the velocity ratio VRO is 6. Okay. Alright, so we are back again now. We can then cross multiply. At this point, we cross multiply. And if I cross multiply, I'll have this times this one times this one. So that is 100 multiplied by my mechanical advantage will be equals to 40 multiplied by 6. Okay, so this will give me 100 MA is equals to 40 times 6 will give me 240. Okay, now if I divide by the coefficient of mechanical advantage, I have mechanical advantage is equals to 240 divided by 100, because the coefficient of mechanical advantage is 100. So if I divide by its coefficient, I'll have MA is equals to 240 divided by 100. So 0 we cancel out 0, and I'll be having that the mechanical advantage is equals to 2.4. So this is my mechanical advantage. Mechanical advantage is 2.4. Now the next thing I'll do now is say mechanical advantage is equals to the load over effort. Mechanical advantage is load over effort. And if you can recall vividly, load is W. Load is W. So I'll be having my mechanical advantage is equals to W over E. Okay. Now you put the value of MA. Mechanical advantage is 2.4. And W is unknown. The effort was given to us as 50 Newton. So I come back here, I have 50. So when I cross multiply now, I'll have W is equals to 2.4 multiplied by 50. Okay, so the load or the weight of that block is 2.4 times 50. And if I multiply that, I'll be having W as 120 Newton. Final answer. Okay, so we have obtained the weight of that block as 120 Newton. I can say therefore W is equals to 120 Newton. That is the weight of the block. It's 120 Newton. Alright. Okay, so we have obtained the weight of that block, which is W. We have obtained W as 120 Newton. Okay, so that is it, 120 Newton. We also saw that the velocity ratio of that pulley system is 6, which is the number of pulleys in the system. Okay, we had it as 6. So the velocity ratio is 6. The effort there applied is 50 Newton. The load is W, which was unknown initially. So we solved, indicating the efficiency as 40%, using the formula for efficiency of a machine, mechanical advantage over velocity ratio times 100. Then efficiency is 40%, converting it to a fraction, that's 40 over 100 equals to MA over, the velocity ratio is 6, so I put the value of velocity ratio there. I then had to cross multiply. So 100 times MA is this, 40 times 6 is this one. So I have 100 MA equals to 240. Okay, 40 times 6 will give me 240. I'll divide by the coefficient of MA. The coefficient of MA is 100. So mechanical advantage will be 240 divided by 100, which is 2.4. So if mechanical advantage is 2.4, so mechanical advantage is load over effort. Now I put the value of load. The load is what? Is W over the effort. Now the value of effort is 50. 50 Newton was applied. The mechanical advantage is 2.4. So in place of MA, I write what? 2.4. I then had to cross multiply. 2.4 times 50 will give me 120 Newton. That is the weight of that block, 120 Newton. Okay, the weight of the block is 120 Newton. Final answer, 120 Newton. Alright, let's move over to the next question quickly. The velocity ratio and efficiency of a system of pulleys are 6 and 80% respectively. How much effort is required to lift a load of mass 120 kg with this system? We are given the acceleration due to gravity as 10 meters per second square. Now let's take a proper analysis of this question. First, we are told that the velocity ratio and the efficiency of the system of pulleys are 6 and 80%. Now we'll take this down. Listing the parameters there, we say that velocity ratio VRO is equal to 6, and we are also told that the efficiency of the system is 80%. Okay? Alright, the velocity ratio is 6 and the efficiency of the system is 80%. How much effort is required to lift a load of mass 120 kg? So we say that the effort E is unknown. And then the mass there is 120 kg. We then look for the load. The load L will be equivalent to mass times acceleration due to gravity. It's just similar to the weight of an object. So the load now will be 120 kg multiplied by 10 meters per second square. So we have the load as 1200 Newton. Alright. So the load there of that object is 1200 Newton. Okay. Now we are asked to find the effort applied. Now you use the formula for efficiency. The efficiency of the system. Use the formula for efficiency. First, let's take proper analysis of this. Okay, this is what I did. Now we then use the formula for efficiency. We say efficiency E is mechanical advantage over velocity ratio times 100 measured in percentage. Okay, so the efficiency is 80%, so that is 80 over 100. When you convert it to a fraction, that is 80 over 100 is equals to the mechanical advantage is unknown. And then we are told that the velocity ratio is 6. If you observe, velocity ratio is 6. So I'll place it there, which is 6. I can then cross multiply. And if I cross multiply, I'll have, say, cross multiply, and then we're having this times this and this times this. Okay, so 100 times MA, and then on the other side we're having 80 times 6. So this will give me 100 times mechanical advantage is equal to 80 times 6. Okay, so that means that mechanical advantage will be equals to 80 times 6 divided by 100. Okay, so I divide by the coefficient. The coefficient of mechanical advantage is 100. So this is 80 times 6 divided by 100. And that will be 80 times 6 will give me, that is 480. Because 8 times 6 is 48. So 8 times 6 is 480 divided by 100. 0 will cancel 0. So I have my mechanical advantage as 4.8. Okay. Okay, then we continue. Now we know that mechanical advantage is load over effort, right? And we put the value of MA there. The mechanical advantage is 4.8 equals to the load is 1200. Effort is unknown. Okay, so I can then cross multiply. So if I cross multiply, or if I interchanging position, now you have E equals to 1200 divided by 4.8. Okay, so what I did is just to interchange position. This one will go here, this one come here. Alright, so if I divide that now, 1200 divided by 4.8 will give me, that will give me 250 Newton. So therefore, the effort applied is 250 newtons. Okay, that is the effort applied to that machine. It's 250 Newton. Okay, so observe everything we did. Okay, we use the formula for mechanical advantage, which is load over effort, making effort subject of formula. We had 250 Newton. And then you see we also made use of the formula for efficiency. The efficiency of the machine is mechanical advantage over velocity ratio times 100. So we substituted the values there. The load is 1002. Okay, sorry. First we took the velocity ratio. The velocity ratio is 6. So we put the value of velocity ratio there as 6. And the efficiency is 80%, which is 80 divided by 100. That's 80%. You convert it to fraction. That is 80 over 100 equals to mechanical advantage all over 6. The velocity ratio 6. Then I had to cross multiply. When I cross multiplied, this 100 will multiply MA and 6 will multiply 80. So that gave me 100 times MA equals to 80 times 6. So dividing by the coefficient of mechanical advantage, MA is equals to 80 times 6 divided by 100. That is, mechanical advantage is 4.8. So finally we solved, and then we arrived at 250 Newton. So MA is equals to load over effort. Put the value of MA here. You substitute it there. So that is 4.8 equals to, the load is 1200 divided by E. So I had to interchange position. This will go, this one come down here. So 1200 divided by 4.8 gave me 250 Newton. Alright, let's look at the next question quickly. Alright, we have another question on the board. It says a block and tackle pulley system is used to lift a load of 20 Newton through a vertical height of 10 meter. If the efficiency of the system is 40%, how much work is done against friction? It says a block and tackle pulley system is used to lift a load of 20 Newton through a vertical height of 10 meter. If the efficiency of the system is 40%, how much work is done against friction? So the next thing we'll do is to list out the parameters in that question quickly. First, we are told that the load L is 20 Newton and it is moved through a vertical height of 10 meters. So that means that the distance moved by load, small l, is 10 meters. Okay, so they say the load is moved through a vertical height of 10 meters. That is the distance moved by load. Now the next thing we'll do now is to look for the work output. I say work output is equals to load times distance moved by load. Okay, so that is L times small l. Now the load there is 20 Newton. 20 Newton times distance moved by load is 10 meters. Alright, so this now will give me 200 joules. Alright, so it is 20 Newton here times the distance moved by load is 10 meters. So 20 times 10 is 200. That's my work output. My work output is 200 joules. Alright. It goes on to say if the efficiency of the system is 40%, how much work is done against friction? So we are told that the efficiency of that machine, efficiency of the machine is 40%. How much work is done against friction? So we say efficiency E is equals to work output over work input times 100 measured in percentage. Okay, so my efficiency is 40%. That's 40 over 100 is equals to my work output W out over work input W in. Okay, so now this means 40 over 100 is equivalent to 40 over 100 times, is equal to work output is 200 joules over work input is unknown. Alright, so that is it. 40 over 100, the 40% now you just convert to a fraction. That's 40 over 100 equals to work output over work input, which is 40 over 100 equals to the work output. We solved it and we had what? 200 joules. If you observe there, 200 joules. Okay, that's my work output, 200 joules. So I now put it there. So in place of work output, I write 200 all over work input. So you make W in subject of formula, I have to cross multiply. If I cross multiply now, I'll be having, so if I cross multiply, I have 40 times work input is equal to 100 times 200. So my work input now is equals to 100 times 200 divided by 40. Alright, so this we cancel out this, and I'll be having 2000 divided by 4. So my work input now will be equal to, you can say 4 go here, 1, 4 into 20 is 5. And then you put your 2 zeros. That will be 500 joules. That's my work input. My work input is 500 joules. Okay? Now we have not stopped. We'll continue. They say we should find the work done against friction. So you say work output is equals to work input minus the work done against friction. Hope we are aware that friction opposes relative motion. So it occurs between two surfaces in contact and it opposes relative motion. So this now will be work input minus what? Work done against friction. Alright? Okay, so that means that if we make this subject of formula, we have work done against friction. Work done against friction will be equal to, you carry this one over here, then take this one here. That's work input minus work output. Okay, so that means this will be work input minus work output, and I had my work input as 500 joules, and I also had the work output as 200 joules. So work done against friction will be 300 joules. Final answer, 300 joules. This is the work done against friction. It's equals to 300 joules. Okay? So that is it. Work output is equals to work input minus work done against friction. And then see that the work done against friction, making a subject of formula. If I make a subject of formula, it will be equals to work input minus work output. So that is it. So it is negative. When I carry a negative value over here, once it crosses the equality sign, it to become positive. So carry it here, then take this one over to this place. So that's work input minus work output. Okay. So the work done against friction will be work input minus the work output. The work input is 500 joules, work output is 200. So that is work done against friction is equals to 300 joules. Okay. Alright, so that is it. That's the solution to that problem. Okay. So observe everything that we did. So observe everything we did there. Alright, we have another question on the board. If you look at this diagram, there are two pulleys. 1, 2. Over here is a block of 40 Newton, and this is a weight W. Okay. It says the figure represents a frictionless pulley system in which a weight W is in equilibrium with a weight 40 Newton. Find the value of W. Okay. We have to find the value of W. So I can say that, okay, these are the options: 13.3 Newton, 20.0 Newton, 40.0 Newton, and 80.0 Newton. Okay, so I can call this one the load, and then I call this one the effort. Now if you see here, they told us that it represents a frictionless pulley system. A frictionless pulley system. So for a frictionless pulley system, frictionless pulley system, the efficiency E is equals to 100%. Efficiency is equals to 100%. Okay. So if the efficiency is 100%, it implies that the mechanical advantage will be equals to velocity ratio. Alright? So for a frictionless pulley system, the efficiency is 100%, which means that the mechanical advantage is equals to velocity ratio. So let's prove it. Let's prove that the mechanical advantage is equals to velocity ratio quickly. So we know that efficiency is equals to mechanical advantage over the velocity ratio times 100. Alright? Now we are told that the efficiency is 100%. So if efficiency E is 100%, converting that to a fraction, that is 100 divided by 100 is equals to mechanical advantage over velocity ratio. So 100 divided by 100 is 1. Okay? So it implies that 1 is equals to MA over VR. If I cross multiply this times this, I'll be having that mechanical advantage is equals to the velocity ratio. So this can only happen for a frictionless pulley. For a frictionless pulley. So for a frictionless pulley system, you find out that the mechanical advantage is equivalent to the velocity ratio, and that the efficiency is what? 100%. So we can call that an ideal machine. It's an ideal machine where the efficiency is 100% and MA is equals to VR. So we also asked to find the value of W. Now it then means that, you see, mechanical advantage is equals to load over effort. Okay? And in that diagram, we took the load as 40 Newton. So what we are looking for now is the effort. So we are told that the load is 40 Newton, and we have the effort as W. W is unknown. Okay? So it then means that my mechanical advantage now is equals to 40 Newton divided by the weight W. Okay? So this is it. The effort is W. Alright? Now, well, remember I stated that mechanical advantage is equals to velocity ratio. So let's find the velocity ratio of that system. You have two pulleys in that system. There are two pulleys there. So it means that the velocity ratio is equals to 2. Okay? So my velocity ratio is equals to the number of pulleys in the system. So it means that my velocity ratio is equals to 2. So velocity ratio is equivalent to the number of pulleys in the system. So I'll come back again. That means it implies that my mechanical advantage equals to velocity ratio is equivalent to 2. Okay, so I put it back into this equation. That is 2 is equals to 40 divided by W. If I interchange position now, I'll have my mechanical advantage, I have W, which is the effort, equals to 40 divided by 2, which is 20 Newton. So 2 here, 1, half of 40 is 20. So I have the effort as 20 Newton. The effort applied is 20 Newton. Okay? Alright, so that is it. Effort is 20 Newton. So the correct answer is option B. Option B, the correct answer to that question is 20 Newton. Alright, so that is it. That's the question. And observe everything that we did, how we solved, and then we arrived at 20 Newton. Say for a frictionless pulley system, the efficiency is 100%, and the mechanical advantage is what equals to the velocity ratio. So you see that the efficiency is mechanical advantage over velocity ratio times 100. So E is 100%. So that is it. 100 over 100 equals to MA over velocity ratio. So if it's 100%, but you just convert to fraction, that's 100 divided by 100, which is 1. So 1 is equals to MA over VR. If I then cross multiply, mechanical advantage is equals to velocity ratio. That's for a frictionless pulley. So also we know that the mechanical advantage is load over effort, and the load is 40 Newton. The effort is W, which is unknown. So that is in place of load I write 40. That's 40 over W. Also the velocity ratio is equals to the number of pulleys in the system. In that diagram we had two pulleys in that diagram. So velocity ratio is what? Is 2. So it implies that our velocity ratio equals to our mechanical advantage equals to velocity ratio is equivalent to 2. Now if I substitute that in place of mechanical advantage, I write 2. That is 2 is equals to 40 divided by W. I will then interchange position. 2 will come down, W will go to that other position. That is W is equals to 40 divided by 2, which gives me 20 Newton. That is the effort they applied. W is 20 Newton. Okay. Alright, we have another question on the board. It says a block and tackle system of pulleys consisting of 4 pulleys is used to raise a load of 500 Newton through a height of 20 meters. If the total work done against friction in the pulley is equivalent to 80 joules, calculate the total work done by the effort. Roman figure 2, the efficiency of the system. Roman figure 3, the effort applied. So let's come back again to this question. They say the block and tackle system of pulleys consisting of 4 pulleys. So since it consists of 4 pulleys, it then means that the velocity ratio, which is equals to the number of pulleys in the system will be equals to 4. Because from that question it says it consists of 4 pulleys. Block and tackle system of pulleys consisting of 4 pulleys. So that means our velocity ratio is 4. It's used to raise a load of 500 Newton through a height of 20 meters. So the load L is 500 Newton, and the distance moved by load small l is equals to 20 meters. Sorry, you see it's a load of 500 Newton through a height of 20 meters. So it is raised through a height of 20 meters. Now that vertical distance moved, or the vertical displacement of 20 meters, is the distance moved by the load. Alright? Okay, then it continues. It says if the total work done against friction in the pulley is equivalent to 800 joules, that is, if the total work done against friction in the pulley is 800 joules, I'll take that down. Before that, first let's find the work output. Work output is equals to load times distance moved by load. That is, work output is equals to the load times distance moved by load is small l, which is the load is 500 Newton Distance moved by load is 20. So 500 times 20 will give me 1000. So we have the load times distance moved by load. The load is 500 and distance moved by load is 20. So 500 times 20 gives me 1000 joules. This is the work output, okay? 1000 joules. Now they said if the total work done against friction in the pulley is equivalent to 800 joules, you say work done against friction is equals to 800 joules. That's the work done against friction is 800 joules. Calculate the total work done by the effort. Okay, so let's look at that Roman figure 1. So we should find the total work done by the efforts. Okay, now work done by effort is equivalent to the work input. Okay, work done by effort is equals to work input, and work done by load is equals to work output. So you say work done by effort is equals to work input. Alright, so we'll come back to that question. The work input is the effort times distance moved by effort. Okay, and also we also recall that efficiency E is the work output over work input times 100 in percentage. Okay, so we'll be making use of this second formula. We'll use this second formula to find the efficiency. That is in Roman figure 2, the efficiency of the system. We'll make use of this formula. Then to find the work inputs, this one can be used when you have the effort and the distance moved by effort. Now there is a relationship between the work done against friction and then the work inputs as well as work output. Now we state that work output is equals to work input minus the work done against friction. Right? And we obtained our work output as 1000 joules. This is it. We had the work output as 1000 joules. So this is 1000 joules equals to the work input is unknown for now. The work input is unknown. The work done against friction is 800 joules. So this is minus 800 joules. If I then collect like terms, take this one over to this place, I'll be having 1000 joules plus 800 joules is equals to my work input. Equals to work input. So I took this minus 800 over to this place, it changed to plus 800. Right? So 1000 plus 800 gives me 1800 joules equals to the work input. So it means that therefore my work input is equals to 1800 joules. Alright, and remember I stated that the work done by effort, see work done by effort is equivalent to the work input. So the work done by effort is also 1800 joules. That is it. Work done by effort is the work input, then work done by load is the work output. So the work put into the machine is 1800 joules, which is the work done by effort. Okay, now how did we get that? He said we use the formula work output equals to work input minus work done against the friction. So the value for work output was 1000, Then that of work done against friction was 800 joules was given to us. So we then made work input subject of formula. That's collecting like terms. This one crossed over there. We had 1000 plus 800 joules, which is 1800. Okay, so we have solved and we have gotten the work input as 1800 joules. Now we'll go back again. We use this formula to find the efficiency of the machine. Efficiency is work output over work input times 100 in percentage. So Roman figure 2 says the efficiency of the system. Efficiency of the system. So efficiency is equals to the work output over work input times 100 in percentage. Or you can say the work done by load, or you can say efficiency is work done by load over work done by effort times 100 measured in percentage. Okay, so my efficiency now will be my work output. We had the work output as 1000 joules, then we had the work input as 1800 multiplied by 100. Okay, so my efficiency will be equals to this. We eliminate this, we cancel this. So 10 times 100 will give me 1000 divided by 18, and that will be my final answer. Will be, please let's come back to this work output. 500 times 20. 500 times 20 will give you 10,000. 500 times 20 is 10,000. That is 10,000 joules. Okay, please, that was a slight mistake. It's 10,000 joules. So my work output is 10,000 joules. The work output is 10,000 joules. Quickly, please correct that. Then it also means that here is also 10,000. 10,000. Okay, here is 10,000 as well. It's 10,000 joules. So 10,000 times 800 will give you 10,800. Okay, so my work input is 10,800. It's 10,800, not 1,800, please. 10,800 joules. Okay, it's 10,800. All right, please just take the little correction. It's 10,800. The work output is 10,000, and the work input will be 10,800. That's 10,000 plus 800 joules. So it also means that we have to make little corrections here as well. This is 10,000 divided by 10,800. All right. So 0 we eliminate 0, and 0 we cancel 0 here. That is 100 times 100 will give me, that's 10,000 divided by 108. Okay, so when I now divide this, now I'll be having, this will give me 92.59%. So my efficiency is approximately 92.6%. Okay, so that's the efficiency of the system, 92.6%. Now the next thing they say we should solve is the effort applied. Effort applied. Effort applied. Effort is E. So we know that efficiency, we know that mechanical advantage is equals to load over effort. Alright? So mechanical advantage is load over effort, but the mechanical advantage is not given. So we then use the formula for efficiency. The formula for efficiency is also mechanical advantage over velocity ratio multiplied by 100. Okay? So we use that, and we have the efficiency as 92.6%. So that will be, put this in place of this, and take this as the denominator, converting that to fraction. That is 92.6 divided by 100 is equals to mechanical advantage over the velocity ratio is 4. Okay, remember, it's a system of 4 pulleys. So velocity ratio is number of pulleys in the system, which is 4. Okay, so velocity ratio is 4. Now if I cross multiply, I'll have 100 times mechanical advantage is equals to 4 times 92.6. Okay, that's when I cross multiply. So it means that my mechanical advantage now will be equals to 4 times 92.6 divided by 100. It means that my mechanical advantage will be equal to, that is 4 times 92.6. I'll give me, so this will give me 370.4 divided by 100. That will be 3.704. Okay, when I divide by 100, so my mechanical advantage is 3.704. Okay. Now the next thing I'll do now is to then use the formula for mechanical advantage. Okay, using the formula for mechanical advantage, which is the load over the effort. Okay, we have the mechanical advantage as 3.704 equals to my load. The load there is 500 Newton. It was given to us. The load is 500 Newton. The effort is what we are looking for. So I can then interchange position, and I'll be having the effort as 500 divided by this, which is 3.704. Okay, so my efforts now will be, if I divide, I'll be having so I have the effort as 134.98. So my effort is 134.98 Newton. Okay, approximating it to the nearest whole number. If I approximate to the nearest whole number, my effort is 135 Newton to the nearest whole number. Okay. Alright, so that is it. Approximating to the nearest whole number, effort is 135 Newton. Okay, so just observe everything that we did there. So observe everything that we did. Okay. So we first found the mechanical advantage, then we used the formula for MA, mechanical advantage is load over effort. Then we made effort subject to formula, we had 135 Newton to the nearest whole number. Okay, this one shows us how we got the work inputs. Work done against friction is equals to 800 joules. So the total work done by effort is equivalent to the work input. Work done by effort is work input, and the work input is effort times distance moved by effort. So basically the formula we used was work output equals to work input minus work done against friction, since work done against friction was given to us. So work output is 10,000 joules, work out input is unknown, work done against friction is 800. So we then made work input subject of formula, and we had 10,000 plus 800, which is 10,800 joules. So my work input is 10,800 joules, similar to work done by effort. The work input is work done by effort, which is 10,000 joules. Okay. So I can say that the efficiency of the system is work output over work input times 100%, which is work done by load over work done by effort. So if I then substitute the values, in place of work output I write 10,000, in place of work input I write 10,800. So if I do my arithmetics, I will arrive at efficiency as 92.59%. Efficiency is approximating it, I have 92.6%. So the effort applied can be gotten with these formulas. Mechanical advantage, load over effort. First, we use the next formula for efficiency. Efficiency is mechanical advantage over velocity ratio. That is 100. We then solved, and so we solved, and after all the solving, all the arithmetics, we arrived at efficiency. We got a mechanical advantage of 3.74 and an effort of 135 Newton. Alright, we'll be stopping here for now.